Hello and welcome to TN Academy. Here we're doing question 2. All right, so we have an a growth equation. Okay, a scientist is conducting an experiment on growth of a certain species of bacteria, and the bacteria can be modeled by the following. Great, where T is time and K is a constant. So now we're asked to write down the value of P naught. P naught is simply the value of our population size at T is equal to 0. So when T is equal to 0, the constant cancels and we just get 1200. So for question A is simply 1200 is equal to P naught. And question AI and then II. Well, I've already explained that, but P naught is simply the initial population of the bacteria. Okay, great. So now, for our next question. 3 hours after the experiment began, the population reached 18,750. Find the value of K. So, the way we do this with B, we know that P is equal to 18,750, and this is at T is equal to 3. So, if we substitute our values into the equation, we equate it to 18,750 equal to 1200 times K to the power of 3. Then we take the, we'll first divide both sides by 1200. Okay. It's equal to K to the power of 3. Take the log of both sides so we can bring that power down. Log 1200. And then when we take the log of K to the power of 3, we know by log rules that the power will be able to come in front of the K. What I'm saying is that 3. This is what I'm saying, okay? So we're gonna, instead of going through all the tedious steps, by me having explained that, we can say that 3 log, we have to divide by 3. This will be equal to log K. Okay, and then when we compute, we can we will find that K is equal to 2.5, okay? All right, so that's our answer to question B. Now we are asked, find the population of bacteria 1 hour and 30 minutes after the experiment began. So this is simply done by substituting all of our values. P at 1 hour and 30 minutes. So 1.5 hours is equal to 1200 times K, which is now 2.5 to the power of 1.5. So when we compute this answer, we should find that our population size is 4,743.41, which we can just round to be 4740. Okay, that is our population size at 1.5 hours after the experiment began. So for our next question, it says the scientist conducts a second experiment with a different species of bacteria. The population size is given by S and modeled by this following equation here, where T is the number of hours and so on and so forth. Now for question D, we're asked to find the value of T when the two population sizes are equal. So the first way we can do this is simply by equating the two equations and solving for T. Okay, so let's do that. Just gonna Get rid of that. 4740. So our first equation, we know K is equal to 2.5 now. So yeah, for D, we're equating P at T and S at T, and we're solving for T, where P at T is equal to 1200 times 2.5 to the power of T, and S is equal to 5000 times 1.65 to the power of T. Okay, so to solve for this, we will be using logs again. The reason being that when we take the log of something such as 2.5t or 1.65t, we're able to bring the power in front of our equation and solve for it. Okay, so if we start by taking the logarithms of both sides, $5,000. 12 times plus 5t. Okay, and then we can bring both of our logs in front of our equations, both of our times t's, our t's. T times 5 and T times log of 1.65. Then if we rearrange our values to bring both of our t's to one side, our times rather, get t times t times log of 2.5 minus t log of 1.65. So we're collecting like terms so that we also get log of 123 minus log of 12,000. And now since our left side, they both have the common term of t, we can factor that out so that we get log 2.5 minus log 1.65 bracket, double the brackets, and this here is repeated. And then the last thing we will do is divide both sides by this inner portion to isolate for t, okay? So that we get t is equal to, just a moment. So we'll get our final answer where t is equal to the following, and after we compute it, should approximate to 3.43 hours. And that is our answer for question D. Okay, now we're asked for our final question, question E, to find the value of m, giving our answer in an integer value. Where, okay. So for what it is for our second equation, We're asked to find the value of m minutes if it takes 2 hours and such minutes for the number of bacteria in the second experiment to reach 19,000. So we're just asked to find time, essentially. So yeah, we'll just solve for our second equation and find time. Okay, where we equate our equation. This is for question E. To 19,000 equal to 5,000 times 1.65 t. We'll rearrange everything. 1.65 t is equal to 19,123 over 5,000. And we'll take the logarithm of both sides so that we can bring the t in front. 65 equal to log 19,000 over 5,000. Okay, and then we divide both sides by log of 1.65 so that we can then compute and solve for t, which should come out to be about 2.66586. Okay, and that's about a little bit more than half an hour. I think if we just multiply 60, if we take 66, let's say 66.5% of 60 minutes, of course, because this is the portion we're looking at here. We're looking at the minutes. It's 2 hours and something minutes. So if we take 66% of 5%, we should find that our answer is about 40 minutes. And that is our answer to question E. Okay? And that's all the answers to the questions today.